Okay. Any questions on what we did last time? Remember what we did last time? Yes, we did rectangles and squares, areas and perimeters. Very good. I almost forgot what we did. Now we're in the 5th week already. The good thing is this week we're going to finish chapter 9. And chapter 9 marks the end of this first half of this course. So that means we're going to start pretty much 2 weeks early for the second half, which will give us plenty of time to do everything we need. So we don't have to rush, which means that, you know how on the week of Thanksgiving, we're supposed to have classes Monday and Wednesday? Well, Wednesday may be an exam day. Actually, Monday and Wednesday both may be exam days to catch up. So, i.e., you could have Thanksgiving. Because we should be very far. We should be almost done with the course by that time. All right. Today, we're going to start chapter 9. Where's my light? Originally, what I have written on your homework assignments for my math lab, I only have it up to section 5. Because once I saw what the other sections were all about, we're going to finish the whole chapter. We're going to do all 8 sections. We're going to do 4 sections today, 4 sections Wednesday, and then that'll finish up chapter 9. The reason being because the first part of the chapter, first 4 sections, or first 5 sections, just deals with the basic rules of what equations are, opposites, absolute values. The last 3 sections deal with math, how to solve equations. So that's why I figured that's much more important. We'll need that for the second half of this course. All right, so let's look at this. Section 1. Also, we've done a lot of this stuff already. So have we talked about signed numbers before? Have we talked about signed numbers? What are signed numbers? What number is that? Look at the blue. Well, for now, okay, good. You can always log onto your computers and go through it that way, like you're watching it at home. I did do that. But signed numbers. Signed numbers are simply that. It's either a positive or a negative. So that's a positive 2. This is a negative 5. What number is that? Positive 3. Because we have 2 negatives. Is that an operation? Is that a math operation? No. How do we change it from negative to equal a positive 3? But if you can distribute, what operation has to be there? Multiplication. If you're doing multiplication, what number is there? Right. So what this really means is that. That really means this. So negative and negative becomes a positive. 1 times 3 is 3. On a number line, zeros in the middle, negatives are to the left, and positives are to the right. Good morning. So negatives to the left. Now, why is that? Why are negatives to the left and positives to the right? What importance does that tell us? Yes, that's one thing. Yes. When we're going to the right, we're increasing numbers. We're going left, going down. Yes, that's true. And that has to do with the values, the size of the numbers. So where would I put -3 on a number line? The negative means to the left, 3 spaces, 3 spaces from 0. Because 0 doesn't have a sign. It's neither positive nor negative. So if we begin at 0, it says go to the left 3 spaces, 1, 2, 3. And there's our number. The negative sign means to the left. The number tells you how many spaces from 0. So if I ask you to graph the number 4, what is that? What does this number tell you to do? Four is actually a positive 4, right? So since it's positive, to the right, 4 spaces from 0. So the number 4 is 4 spaces from 0. 1, 2, 3, 4. I know you guys know these numbers. You've seen them before, but this is really what it really means. Good morning. So this is what negatives and positive really mean. Yeah, when I ask you to graph -3, you can just plug it there. But why? What does it really mean? The sign and the number. The sign tells us which direction to go. The number tells us number of spaces from 0. Why from 0? Zero is a starting point. It's nothing. That's where all numbers begin, because it's neither positive nor negative. That's where everything begins. If it's positive, it goes to the right. If it's negative, it goes to the left. And as you said earlier, you're absolutely correct. If it gets higher, if it gets bigger, it goes to the right, it gets smaller to the left, which is where we get these symbols from. What are these called? Was it? Yes. This one is called less than. This one is called greater than. Together, these things are called inequalities. What does inequality mean? That's exactly what it means. Not equal. That's what the word inequality means, not equal. And these are called strictly inequalities because they cannot be equal. These are called strictly inequalities. Now, why does it matter which direction it's pointing? Why is this less than and this greater than? That's what I remember from elementary school. The alligator always eats the bigger piece of meat. That's exactly, that's I always said. So 2 is less than 5. But remember, I told you first day of class, mathematics is a language. How do you read math? From left to right. If you read left to right, so this number is related to this number. 2 is less than. One way you could do it, it points to the smaller number, or it eats the bigger number. Good morning. If you think of an alligator, it always goes for a bigger piece of meat. Or it points to the small number. Good morning. But remember, okay, that's because we read left to right. What if we read this that way? How would you read that? Right. If you go this way, it would be 5 is greater than 2. What symbol goes there? To the left side. Yes, but that's not a math statement. It points to the left because remember, it always points to the smaller number. But this is called a what symbol? Less than. So we use the less than symbol. But you're right, it points to the left. How about this one? Right. 3 is greater than -9. Why is 3 greater than -9? No. Because if here's 0, let's say -9 is to the left, it's over here, and 3 is over here. Remember, larger numbers are to the right of smaller numbers. On a number line, that's the reason we talk about number lines first. If you plot the numbers on a number line, the number to the right is always going to be bigger than the number on the left. So since 3 is bigger than 9, are these statements the same? Are those two statements the same? Yeah, because 3 is bigger than -9, which means that -9 is less than 3. It all depends on how the numbers are situated in the question. How about this one? Is so which direction is it pointing? It always points to the smaller number. So yeah, so you said it correctly. -5 is greater than -7. That's the first part. That's the first, but you have to put the right symbol. And that's the greater than, because this number is bigger than this number and it points to the smaller. Want to do some more of these? Are you okay? More? Okay, yes. Let me pull up. Let's see here. How about, I'll put a couple up here. -11, -2, -72, -75, -1, 0. Okay, I want you to do two things here. Put the right inequality symbol on there and put them on a graph, on a number line. So the first number line is there. The second number line. And the third number line. So the first one, what direction is it pointing? To the left, because -11 is smaller than -2. So how would I put this on a number line? Where is -11? Very far to the left or closer to 0? Very far. Where's -2? It's closer to 0. So there we have our two numbers. And since -11 is to the left of -2, it's less than. How about the next one? -72, -75 is what? So which direction does it point? Yes, it points to the right, because 75 is -75 is smaller than -72. -75 is there. -72 is there. Since -72 is further to the right than -75, it's bigger. And the inequality always points to the smaller number. How about the last one? Okay, but what direction does it put it? So what's that symbol called? Less than. -1 is less than 0. -1 is to the left. So -1 is less than 0. Again, the arrow points to the smaller number. Makes okay there? We have -20 and 20. Obviously, we know that now that -20 is less than +20. How can we make them equal? No, because if you put less than or equal to, that doesn't make it always equal to. It can mean it's less than or equal to. But it's a good try though. Okay, let's do this. Pretend you live in Irving. Dallas is 20 miles to the east. Fort Worth is 20 miles to the west. When you say you're going to go to Dallas or go to Fort Worth, do you ever say, well, somebody asks you how far it is? Do you say, oh, Dallas is -20 miles away? Fort Worth is 20 miles away? No. How do you say it? You just simply say Dallas is 20 miles away, or however many miles it is. Now that's where we introduce absolute values. Absolute values represents distance a number is from 0. Does distance have a positive or a negative? No. You simply say, go 5 miles this way, turn left, 4 miles. It has no sign. This distance is an absolute. What an absolute value does, it tells us how far a number is from 0. So how far is the number 3 from 0? 3 spaces. How far is the number -8 from 0? 8 spaces. So what the absolute value does, it erases inside there, inside the absolute values, it erases the negative symbol. How about this? What would the answer be here? What was that? 8. Okay. Let me give you another one also. How about that one? What's that? It's an absolute value. What is a value? A value is a number, one number. It's not an equation. Absolute values are like parentheses. When you have that, you have to do inside there first. So in this first one, -3 minus 5. They're both negatives. So you say 5 plus 3 is 8. So the absolute value of -8 is 8, because -8 is 8 spaces away from 0. But the second one, since the signs are different, take the sign of the larger. 5 minus 3 is 2. The absolute value of 2 is 2. You cannot take the absolute value of an equation, because it's not called an absolute equation. It's called an absolute value. You have to work out the equation first and then take the absolute value. Remember order of operations? Do inside the parentheses, and special operations, do inside there first and then do it. It's the same logic here. Are we okay with that? Let's look at some other absolute values. What's that going to be? Why? Exactly. Yes, good point. Excellent. Order of operations. You have to do special operations first. So leave this alone. What's the absolute value of -5? And there's your answer. You have to treat them separately because absolute value is its own operation. Very good. How about that one? It's the treatment same as you do parentheses. What do you have to do first? You have to do inside the special, so you have to do this one. What's the absolute value of 3? 3. Then we have to do inside these absolute values. What's the absolute value of -3? 3. And this negative stays out there. And there's your answer. It doesn't matter how big or how ugly it looks. Follow the rules of math. You can't go wrong. You only go wrong when you start changing the rules of math, the order of operations, or what they tell you to do. What are opposite numbers? Numbers with the same value, but different signs. Opposite numbers simply mean numbers with different signs. So what's the opposite of -5? It's 5, because it's the same number, but different signs. Absolute value of, the opposite of 3, -3. You notice I didn't say -3. The word minus really means adding a negative number. You see how this stuff connects now? Negative numbers simply means you go to the left. Positive numbers mean you go to the right. So if I gave you this, 13 minus 5. What that really means is 13 plus a negative 5. What does that equal? Well, let's see. We start off with a number line. Here's 0. What direction does this number go? To the right 13 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we're changing 5. Which direction does it go? It goes to the left 5 spaces. So 1, 2, 3, 4, 5. So this is 12, 11, 10, 9, 8. So that's what our answer is. Our answer is 8. 13 minus 5 is 8. This is what it really means. Because there is no subtraction. It's simply adding in the opposite direction. Have you all seen this before? Everybody has. So whenever you see a negative sign, it simply means change direction and go that many spaces. Go 13 miles and then come back 5 miles. That's what it means. Or get 13 apples and put back 5 of them. It's all it means the same. It just means the opposite. Instead of taking, I'm putting back. What number is that? Why is it positive 13? Yes. But have we talked about the rule of distributivity yet in this case, in different signs? What this really means, remember, a negative simply means change direction. So from 0, this number says go to the left 13 spaces, right? But before we do that, we have to change directions again. So we're supposed to go to the left and then back to the right. So that really means go 13 spaces this way. And yes, you're absolutely correct. What this really means is -1 times a -13. If we're going to use the rules of math, then we have to have numbers there. This is a multiplication. Negative times negative is positive. 1 times 13 is 13. So the answer is positive 13. Try to get used to treating the numbers and the signs differently when you do equations. It's going to make life a lot easier for you. Treat the numbers and the signs differently. What's the opposite of this number? $205. Because remember, what does opposite do? Just changes the sign. It changes directions. It doesn't change the flip of it. What would this number be called? There's a difference. If you just change the signs, that's the opposite. Just change the signs. Now with this one, if I'm multiplying two numbers and I multiply by the inverse, what's going to happen is I'm going to end up with 1. If I flip it, if I flip a fraction, that's giving me the inverse. And that's not what I'm asking for. If I ask for the opposite, all I want is a change of signs. And here's a rule, you know you have the opposite. A number plus its opposite always equals 0. A number plus its opposite always equals 0. So this is how you test. If the question is asking, find me the opposite of this, what's the opposite of -3? 3. If I add 3 plus -3, it has to equal 0. If it doesn't equal 0, it's not the opposite. So far, so good. You know this stuff, it's in the back of your head, but this is the reason why. We have to know this because we're going to build from here. All right, so that's section 1 of chapter 9. Okay, section 2. Of chapter 9 deals with adding and subtracting numbers. Actually, find numbers. Yes.
When you did the inverse, did it negative at first?
Well, yeah, when I did the inverse, let me get that for you. When I first did the inverse only works with multiplication or division. So the inverse of this, in other words, the opposite of that is negative. So it has to, because when you multiply them together, it has to equal 1. Okay, doc. Let's look at this section 2 now. Like we talked about earlier. Three plus 5. Do this addition using a number line. How would you do this using a number line? You start with 0. So you go 3 to the right because it's positive. Yeah. You keep on going to the right since it's positive, 5 more spaces. It's 4, 5, 6, 7, 8. There's 3 of these and there's 5 of these, and they're both going that direction. That's what addition really means. And yes, I know you all know that this equaled 8. but this is the proof of why it's happening. There has to be a proof. You have to know why something happens, why it does what it does. If you don't know why it does what it does, then it's easy to get confused and lost. So understanding what's happening, all this is the important part. Now the additive inverse. The additive inverse is what we just talked about. It's what we call the opposite number. What's the additive inverse? What do we add to 5 to equal 0? Yeah, you add the opposite. 5 plus -5 equals 0. That's called the additive inverse. Because if I add the opposite to it, it becomes 0. -3 plus what equals 0? Yeah. If this is -3, the opposite of that is 3. Why is that important? When will we ever use the additive inverse property? Later on in this chapter. I'm going to give you equations to actually solve. X plus 5 equals 8. We have to solve for X. How do we do that? We have to get rid of what? We have to get rid of that. We have to make that equal 0. How do you make that equal 0? Well, add the opposite to it. Since it's addition, what's the opposite of it? -5. Because it's equality, I do it to both sides. The golden rule, whatever you do to one side, do the other. So these cancel out because we know there's 0. 8 minus 5 is 3. And we'll use that to solve equations from here on out. We'll do those. Now you know why we do those. Because remember, in math, you can't do anything unless there's a reason you can do it. All right, that's addition part. We'll do some examples of these in a second. Let's look at subtraction. Remember, subtraction really doesn't exist. What does this really mean? What does X minus Y really mean? It means X plus the opposite of Y. That's what it means. There is no, in reality, there is no subtraction. It's an addition of a negative number. A number goes the opposite direction. Six minus 4. That's the same thing as 6 plus a -4. So on a number line, it first says go +6. 1, 2, 3, 4, 5, 6. So we go 1, 2, 4, 5, 6. And then we're changing, going opposite direction now, 4 spaces. 1, 2, 3, 4. And there's your answer. 6 minus 4 is 2. Again, I know you know that, but this is the reason why it happens. Because we're going to use these rules later on when we start solving things. Yes, it seems pretty Mickey Mouse right now, but we have to know these rules. These are where the rules, where people mess up in math later on, they mess up because they don't know the basic rules. That's why I go through these rules all the time. Let's see. Work this one out for me. Remember your order of operations. So what do you do first? Using the order of operations. Order of operations, remember, read left to right. Can you do anything inside the parentheses? No, there's not equations, so you can't do it. So that is the first thing. You can't do special operations. Next, are there any multiplication divisions? Yes, these are multiplications. That's the same thing as -1 times -3. Negative and negative is a positive. 1 times 3 is 3. So yes, we have multiplication. So since we can't do anything with parentheses, we have to get rid of the parentheses by multiplication. So positive times negative is what? Why is it negative? Whenever you multiply the same signs, two numbers of the same signs, because you only have one sign between them. If it has the same signs as you're multiplying them, it becomes positive. If they have opposite signs and you multiply them together, the sign becomes negative. So since positive is negative, opposite signs, it becomes a negative 3. And same thing here. Negative of a negative, since they're the same sign, it becomes positive. So our first job, if you can't do inside the parentheses, you have to get rid of the parentheses by distributivity, by multiplying. Now, there's read left to right, no special operations, no multiplication division. So all we have left is addition subtraction, read left to right. 4 minus 3 is 1. Bring down everything else. Positive 1 minus 6. Since 6 is bigger, the answer is negative. 6 minus 1 is 5. Negative 5 plus 2. 5 is bigger, so it's negative, so the answer is negative. 5 minus 2 is 3, and there you have it.
Signs all at once, as well as with the that correct?
Yes, yes. As long as you follow the rule, you follow the rules though. You did the first one first, and then you did that, and then you did the last one. Yes. As long as you follow, there's a rule that says you could do what you did. Yeah, you'll get the right answer. That's the beautiful thing about math. If you follow the rules, you can only come up with an answer that's correct. The only time you ever get a wrong answer is if you deviate from the rules. If you make up your own rule, then you'll get a wrong answer. Sometimes. Let's do another one. Let me pull it from the homework assignments. Let's look at number 32. -8/5 plus -3/10. -8/5 plus -3/10. I know y'all like fractions. You couldn't wait. Okay, the beautiful thing is whenever we add and subtract fractions, how many of y'all like using the butterfly method? I do. So we'll look at both ways. We'll use it with the butterfly. And then not. So we have -8/5 plus -3/10. Using the butterfly method, if you have a negative in front of your fraction, that negative belongs to the top number. So there's a plus, that negative belongs to the top number. Now we could. So diagonally, -8 times 10 is -80. -3 times 5 is -15. Plus 5 times 10 is 50. -80. There's a plus. -15 over 50. So since they're both negatives, the answer is negative. 80 plus 15 is 95. What do we do next? You have to simplify. This is now where it's iffy on how which method you do. You could simplify this. What kind of fraction is this? It's an improper fraction because the top number is bigger than the bottom number. So how many times does 50 go into 95? One time. So the answer is negative. One time. How many left over? 95 minus 50 is 45. They both have fives in common. How do we know they both have fives in common? Look at the last digit. If the last digit is a 5 or a 0, it's divisible by 5. So how many times is 5 going to 45? 9 times. 5 goes into 50, 10 times. There you have it. There's your answer. So that's using the butterfly method. If you didn't use the butterfly method, then the first thing you'd have to do is get rid of the parentheses. You have opposite signs, so it becomes what? If you have opposite signs, it becomes a negative. Now you have to get common denominators. What's the smallest number 5 and 10 both fit into? 10. Very good. 5 times what is 10? So we're going to top. 8 times 2 is 16. 10's already there, so leave the top number alone. Since you have a common denominator, just worry about the top now. Negative 16 minus 3. They're both negative. 16 plus 3 is 19. The answer is negative. 10 goes in 19 one time with 9 left over. It's the same thing either way. Choose which one you like the best. It's the only 2 ways you can do it. All right, so again, I know y'all aren't fans of fractions. That's why I'm going to throw them in there as often as we can. Just get over the fear and learn how to use them. Let's do one more example now with everything we used here today so far. So we're going to do absolute value of 7 plus 2 plus negative 2 plus 4. Order of operations, what do you have to do first? We have to do inside the special operation. So absolute value, negative 7 plus 2. Since they're opposite signs, the 7's bigger. 7 minus 2 is 5. Write the rest of it down. Again, left to right, special operations. Yes, we have an absolute value right here. What's the absolute value of negative 5? Read left to right. Here's special operation, but we can't do anything inside there. So no more special operations. Are there any multiplication divisions? Here's a multiplication right here. Remember, if you have a parenthesis, there's an automatically, if there's nothing in front of it, it's automatically a 1 in front of it. If you have a parenthesis, if there's no number or letter in front of it, there's always a number 1 in front of there. So positive times negative is a negative. 1 times 2 is 2. Left to right, any special operations? No. Multiplication divisions? No. So 5 minus 2 is 3. 3 plus 4 is 7. 7 is the answer. Everybody okay with that? So again, you follow how I do these questions every time I ask the same questions. Read left to right. Are there any special operations? Are there any multiplication division? Are there any just, that's how you solve questions all the time. I don't care how big they are or how small. It's the same steps. All right. That does it for section 2. Now section 3. Sign numbers. Section 3, multiplication and division of signed numbers. Remember, I'm trying to get everybody to think of the same way. Treat the numbers. Treat the signs and numbers separately. So when you're multiplying, -2 is -5. So treat them separately. So first thing I look at, negative times negative. Since the signs are the same, it becomes a positive. Then the numbers, 2 times 5 is 10. You don't have to put the plus in front of the 10, so the answer is just 10. Three times -4. Again, the sign in front of the 3 is positive, so positive times negative is negative. 3 times 4 is 12, and there's your answer. Okay, now we have a pretty long equation. Still the same thing. Treat the signs and numbers differently. Separate them. Is the answer going to be positive or negative? How do you know that? Very good. Remember, you very good. You remember that? Yes. Because we have an odd number of lines. So if the number of negative numbers is odd, the answer will be negative. So all you do is count the number of negatives. 1, 2, 3. Since we have 3 negatives, the answers are going to be negative. If the number of negative, actually not numbers, I should say signs, is even, the answer will be positive. So if the number of negative signs is odd, the answer is going to be negative. If the number of negative signs is even, it'll be positive. We have 1, 2, 3. Okay, this only works if you have only multiplication and division. You notice there's no plus and minus equations in there. It's just all multiplied or divided. So we know the answer is going to be negative. All I have to do now is what? 4 times 2 is 8. 8 times 3 is 24. 24 times 2 is 48. 48 times 3, 144. The answer is negative 144. Remember, since these are all multiplied, 4 times 2 is 8. 8 times 3 is 24. 24 times 2 is 48. And so forth. Now you see why I separate the signs from the numbers. Once I know the answer is going to be negative, all I got to do is multiply the numbers. Don't worry about multiply a negative by positive. Do that separately. Let's look at division example. Let's do that one. Okay, go ahead and work it out, and then I'll work it out for you. First off, is the answer going to be positive or negative? Negative? Let's see. We have 1, 2, 3, 4, 5 negatives. It's odd. So the answer is going to be negative. Very good. So that is the first part. So all we have to worry about now are the numbers. Worry about the signs first. Now, because it's multiplication, I mean, and division, we reduce first before we multiply. Always reduce before you multiply. Before we do that, let's break them down to the smallest pieces. 3 is as far as it can go. 2 is as far. What is 6 made up of? 2 times 3. What is 8 made up of? Yeah, 8 is 4 times 2. 2 so it's 2 times 2 times 2. How about 12? 6 times 2, 2 times 3, so it's 2, 2, 3. 4 is made up of 2 times 2. 9 is 3 times 3. What's that called? What process did we just do there? Prime factorization. Perfect. Yes. Prime factorization. We broke it down to its smallest pieces because now what do we do next? Cancel. Anything same on top, cancel with the bottom. This 3 cancels with that 3. This 2 with that 2. That 2 with that 2. That 2 with that 2. That 2 with that 2. This 3 with this 3. What do we have left? So the answer is -2/3. Now, how many of y'all were multiplying across first before we simplify? Don't do that, because if you multiply across, the numbers get bigger and bigger and bigger. And what do you do next? You have to break them down smaller again. No, it's already the smallest. Let's go down further from there. So whenever dividing, reduce first, then multiply. Numerator times numerator, denominator times denominator. Reduce first. Make the numbers small before you go any further. Want to try another one? All right, let's try another one. Let me pick one from the homework assignment or the end of the chapter, end of the section. Yeah, I can make one up. There. Okay, before we can go on with this question, before you can tell me if the answer to be positive or negative, what do you have to do first? We have 2 equations that have to be worked on inside the parentheses first. Two minus 5. Since 5 is bigger than 2, it's negative. 5 minus 2 is 3. And then this one, 4 minus 1 is 3. Okay, now you can tell me, is the answer going to be positive or negative? We have 1, 2, 3. It's an odd number, so the answer is going to be negative. So we figure out the sign. So we don't have to worry about the signs anymore. Let's look at these numbers. 3 is a prime number. Can't go any further. What can 4 break down into? 2 and 2. 6 can break down into 2 and 3. And 15? 18? 2 times 3 times 3. 3 times 3 is 9, times 2 is 18. 3 is a prime number. 12. 2 times 2 times 3. And 3. So the hard part's done. We know the answer is negative. This 3 cancels with that 3. This 2 cancels with that 2. This 2 cancels with that 2. That 2 with that 2. This 3 with this 3. This 3 with this 3. Nothing else. So we simply have 5 on top. 3 times 3 is 9 on the bottom. And there's our answer. If you break it down like that, it shouldn't take much time at all. The hardest part is finding the prime factors of this. That's the hardest part. Once you do that, just cancel and you're done. Everything's finished for you. All right, so that does it for section 3. Multiplying and dividing signed numbers. Section 4. Order of operations. Special operations first. By special operations, I mean parentheses, brackets, squiggly brackets, absolute values, radicals, and anything else. There are over 400 of them. So you do what's inside those and you finish those. Then we do multiplication and division. And on the last sweep, we do addition and subtraction. Reading left to right. This thing doesn't say that multiplication is more important than division or addition is more important. They're both on the same level, so they're both as important as each other. Whatever you get to, reading left to right. All right. Let me look at that. There. Let's look at this. Write a couple more of these down. So I'm flipping back and forth. Ooh, okay, that's next. All right. Order of operations with everything we've discussed so far. Addition, subtraction, multiplication, division, exponents, absolute values, you name it, it's going to be thrown in there. What do you do first here? Look at that. Are there any special operations? Yeah, exponents. This is an exponent. So we have to do this first. What does an exponent mean? Yeah, it means the base -6 times -6. Negative times negative is positive. 6 times 6 is 36. So it's 36. And write everything else down. So we did the special operations first. Are there any more special operations? No, but now we have addition, multiplication, division, reading left to right. Here's a division right here. Eight divided by 2 is 4. Again, left to right, no special operations. Multiplication, division, yes, multiplication's right here. So negative times negative is a positive. 4 times 3 is 12. No special operations, no multiplication, division. So I just add 36 plus 12 is 48. Okay. So if you got this, this is as tough as they come. Let's look at the next one. You have to remember, the biggest mistake students are going to do is going to do 2 times -3 first. That'll throw off your entire answer. So keep it, follow those as 3 basic rules of order of operations. All right, let's look at these 4. And then we'll do division ones. So do the top 2. Right, the first one, left to right, any special operations? Yeah, here's a special operation there. 4 squared, what does that mean? 4 times 4, which is? Repeat the process, left to right, any special operations? Yes. Right there, so it's 3 times 3 is 9. No more special operations, any multiplication, division? Right here, multiplication. You can't have 2 signs next to each other. A positive times a negative is a negative. No special ops, no multiplication, division, so left to right. 16 plus 9, 25. 25 minus 8, 17. Very good. All right, the next one. Left, right, special ops. -4 squared is what? Positive 16, because it's -4 times -4 is positive 16. Left to right, here's a special operation. -3 times -3 is positive 9. No more special ops, no more multiplication division. And so we just left to right. 16 plus 9, 25. 25 plus 5 is 30. Very good. Are they getting easier? I hope. Yeah, because that's the whole goal. If they're getting a little bit easier, even if it's not 100% easier, that's the sign that you're learning. If it's getting easier than it was 2 weeks ago. So what do you do first here? No. Inside the parenthesis first. Don't do the distributivity. The distributive, I should now modify that. Distributivity only works if there's a variable inside there. If there's a letter inside there with a number. If it's not, then just treat the math. Treat it as an equation first. 7, the opposite signs. 13 is bigger, so the answer is going to be negative. 13 minus 7 is 8. Is it 8? I thought about it. I wanted to put it down there. It was wrong. It's -6, right? Divided by -10. Any more special operations? No. So left, right. Any multiplication division? Reading left, right. We have multiplication right here. Negative times negative is a positive. 5 times 6 is 30. What do we do now? Is the answer going to be positive or negative? Negative, because what this equation looks like is like this. Since there's only one negative sign, the answer is negative. The zeros cancel, so the answer is -3. And whenever you're dividing numbers that have zeros at the end, you can cancel them out. As many zeros as they have in common. All right, the next one. Again. Look for special operations. Right. Any special operations? No. So I mean, there are, but we can't do anything inside the parentheses. So all special operations are gone. Multiplication division, yes. Positive is positive. 2 times 5 is 10. Bring down everything else. Repeat the process. No special ops. Nothing we can do. Multiplication division, yes. Here's a multiplication. Negative times positive is negative. 3 times 4 is 12. No special operations we can do. Here's a multiplication. Positive times positive is a positive. 5 times 3 is 15. No special ops, no multiplication division, so addition, subtraction. Positive 10 minus 12. 12 is bigger, it's negative. 12 minus 10 is -2. Opposite signs, 15 is bigger, so the answer is positive. 15 minus 2 is 13. With practice, it's those questions you'll hear over and over and over. Are there any special operations? Are there multiplication division? And just, once you do that, once you start seeing every equation the same way, it doesn't matter how big or how small it is, it's always going to have the same steps. And logically, every equation should be able to be solved without error if you follow the same steps. Don't take any shortcuts, because if you take shortcuts, chances are it could blow up in your face. All right, next part, divisions. How do you do divisions? This will be the last part. We'll stop here for today because I know your brain's getting like mashed potatoes now. We're going to stop after these 4 questions, and then we'll finish up the chapter next on Wednesday. In the first one, can you tell me if it's going to be positive or negative just by looking at it? No, you can't. Because that trick only works if they're all multiplied or divided together. The minute you put pluses and minuses inside here, rules have changed. So you can't tell me if the answer is going to be positive or negative at this stage. So what you can do, though, is treat the top and the bottom separately. Because there's pluses and minuses, treat them both separately. So on the top, any special operations? Yes. Here's an exponent. So we have -6. 3 squared is 9. Because you could treat the top and bottom separately, we could look at the bottom. Any special operations? No. Multiplication, division? No. So we read left to right. 7 minus 9. Since 9's bigger, it's negative, so it's negative. 9 minus 7 is -2. Bring down 3. Again, you're treating the top and the bottom separately. They're 2 separate equations. The top. Any special operations? Well, there's a parenthesis, but we can't do anything inside there. Since you can't do anything inside the parenthesis, you have to get rid of it. Multiplication. Negative times negative is a positive. There's a 1 there. 1 times 7 is 7. And on the bottom, they're both negatives. 2 plus 3 is 5. Top, no special operations, no multiplication division. So we just add and subtract. -6 plus 9. 9's bigger, so the answer is positive. 9 minus 6 is 3. Over -5. 3 plus 7 is 10. Now you can tell me the answer. Now is the only time you can tell me the answer to be positive or negative. Is the answer going to be positive or negative? It's going to be negative because we only have 1 negative sign. 10 divided by 5 is 2. And there's your answer. Get it? Where'd you make a mistake?
I mean, I thought that, but it's just more. I have more trouble with like.
At this point? But you got 10 over 5, right? So if you got that far, I'm happy. You mess up with the sign? Again, it's a sign. It's going to hurt. That's what I said. Treat them both separately. Always ask yourself, do the signs differently. Negative and negative. You're adding, subtracting. They're both negatives, so the answer will be negative. They're not multiplying, they're adding together. So -2 plus -3, they're both negatives, so -5. Yeah, so yeah, again, that's the part I don't know. I can't help because you know the rules. You just have to be very careful about them. But yeah, if you got this far, I'm happy. The signs you just be very careful with. Excellent. Which one? Actually, no, your voice is very, very, very subdued. Could you sit in the front from now on so I can hear you better? No, no, not today. But can somebody yell out what she said? Not only just not something about. I said, what did you actually? Louder, please. What do you mean 3 by 3? A what? You can't do prime. When you have pluses and minuses, you can't do prime factor. Prime factorization only works at the very end when you're ready to cancel. But once you have pluses and minuses, prime factor, nothing, that doesn't work anymore. You have to use the rules of math. You can only prime factorize when you get to the very end, if there's no more pluses and minuses. That's a very question, because that's where a lot of mistakes happen. Like right here, so you say, well, the 3 goes in the 9. No, because this is an equation right now. That's a very good question. So do not use prime factorization until the very, very, very end. All right, on the top, special operations. Yes. 3 squared. 3 squared is 9. All right, write everything else down. What about the bottom? Left, right, special operation. We have this parenthesis. We can do inside there. What is this going to give us? 3 times 5. 15, right? That's the first step. What can we do on top of the second step? The second round. Reading left to right. Here's a special operation. We could do inside the parentheses. -1 minus 2. They're both negative. So you add them. 1 plus 2 is 3. And on the bottom, we have another special operations right here, parentheses. Negative times positive is negative. 6 times 9, 54. Repeat the process. On top, are there any special operations? There is parentheses, but we can't do anything inside there, so no special ops. Now we have to multiply to get rid of the parentheses. Positive times negative is a negative. 4 times 3 is 12. Same on the bottom. Positive times positive is positive. 4 times 15 is 60. So nothing to do on top, because they're all just a distance fraction. So we do left to right. 9 minus 12. 12 is bigger, it's negative. 12 minus 9 is 3. Minus 25. Here we have multiplication. Positive times negative is a negative. 1 times 54 is 54. Negative 3 minus 25, they're both negative. 25 plus 3 is 28. Negative 4 plus 60, 60 is bigger, that's positive. 60 minus 4 is 56. Fifty-six minus 54 is 2. Since only one answer is negative, 28 divided by 2 is 14. The answer is negative 14. Right, space. Again, if you just take each step, don't rush through your equation. I do each equation. I do one on top, I do one on the bottom, then I go to the next line. Don't rush your equations. That's where the errors happen. If you try to rush, get overconfident, you'll make mistakes. Have you ever seen those YouTube videos, the fails? Those athletes got too cocky and they trip at right before the end zone. They slow down, wave to the crowd, and somebody passes them up, crosses the line. Yeah, those are fails. All right, 2 more. This is going to be pretty interesting because the rules now, left to right, any special operations? Yes. Negative 5 squared. Negative 5 squared is negative 5 times negative 5 is positive 25. Left to right, special operations. Inside the parentheses. 9 minus 17, they're opposite signs. 17 is bigger, so the answer is negative. 17 minus 9 is 8. Bringing everything else down. Read left, right. Any special operations? Here's the first one. It's exponents. Negative 8 times negative 8 is positive 64. So since we have fractions, we have 25 times 64 divided by negative 10 squared. Negative 10 is a positive 100. $64 times 25. 5 times 4 is 20. 5 times 6 is 30. Times 3 is 32. 2 times 4 is 8. 2 times 6 is 12. So it's 1,600 divided by 100. And then the zeros cancel. So 16 over 1 is 16. What do y'all think? I mean, does it look logical, at least what I'm doing? If the answer is no, then there should be tons of questions. Because I'm just following the basic rules of math. We haven't done anything spectacular yet. It's the same order of operations rules I've done so far. Nothing more, nothing less. Yes. Again, inside the parentheses, yes. So that's why, again, order of operations. Are there any special operations? Yeah, here's parentheses. Do inside the parentheses first. I can't do the exponent until I finish the inside the equation. Yeah, that's where it's gonna throw people first, right there. Good question. It's good point. Is when you have an equation like this, finish that up first and then do the exponent. So even in special operations, they have a hierarchy. There's no real particular one. It's inside the parentheses first, because I can't do the exponent until I have a number. Yes. No. Oh, yeah. Because this is inside the parentheses, I cannot do this exponent until this is fixed. So 9 minus 17 is -8. Now I can go -8 times -8. Because yes, you're absolutely correct. Is 9 minus 17 times 9 minus 17. You have to do inside the parentheses. So you have -8, which is what this says. It's just an extra writing. The more you write, the more chance of error you have, because you'll negative signs all over the place. So again, yes, I see how that come into logic. Yes, because it's how you interpret these questions, and that just comes with practice. Yes.
Got down to 25, 64, divided by -10.
Yes.
The division signs, what tells you to turn it into a fraction.
Yes, because that's exactly, that means that symbol there. Because remember the old days, it was 8 divided by 4 means 8 divided by 4. Yes, yeah. You're right. Normally you don't see a lot of these and you convert them, but that's what it means. I like it in this top and bottom format better. So whenever you see that, anything behind there is your denominator. So anything after that symbol is the bottom number. That's anything back there is the bottom number. All right, y'all try this one yet? Try that one. This means. All right. Whenever you have a fraction raised to a power, what that really means is I have 1/2, -1/2, -1/2. So whenever you multiply fractions, nothing cancels. So negative times negative is a positive. 1 times 1 is 1. 2 times 2 is 4. So what you do is this exponent goes to both top and bottom. Whenever you have fractions raised to a power, that power goes to the top number and the bottom number. So -1 squared is 1, 2 squared is 4. Minus not equals. Since the bottom numbers are the same, we just worry about the top. Three minus 7. 7 is bigger than 3, so it's negative. 7 minus 3 is 4. two negative signs becomes a positive. So we have 1/4 plus 4/4. You have a common denominator, so you worry about the top. Okay. What's that? Yes. Yes. What would I do next? How many times is 4 going to 5? With how many left over? With whatever the bottom is, has to stay on the bottom. Yeah, so it's 1. Very good. Yes. There's an improper fraction. I know how tempted you would be right here to make it 1. You still get 1 1/4, right? Because 1 plus 1/4 is 1 and 1/4, right?
I got 1, but then I realized that I can't plus these on it.
Remember, well, as I'm saying is, if you have a number, say 3, and you add a fraction to it, that's what it equals. That it's just a shortcut. Because we could make this 15/5 plus 1/5 makes it 16/5. 5 goes in 16 3 times with 1 left over. So instead of going through the whole common denominator thing, just put these two together. That's what a mixed number means, really.
What if the 3, like example, the 3 plus 1/5 was an equation, like,
Ah.
so without other fractions? And that 3 would be.
Yes, because now if it's part of a larger equation, yes, then we have to worry about denominators.
Or would it be the same then? Like,
Well, actually, you could leave it the same. You know, this would be 3 1/5. But now you have to make this an improper fraction. 3 times 5 is 15, so it'd be 16/5 plus 2/3. And then you could do the butterfly from there. Yes, yes. I mean, there's the beautiful thing about mathematics is as long as there's a rule, and there's many ways you can do it, but there's only one answer once everything comes together. Excellent points. Yes. So in other words, it doesn't matter, but here's the thing. If you have an integer plus a fraction, you can combine them as a mixed number. Even if it's in an equation, but in an equation, you still have to get common denominators. You have to solve them, put them all together. So we have to convert that into a mixed number or improper fraction and go on from there. Woo, was that a lot of hard stuff or was just busy stuff? I mean, I know you've seen it before, and I'll tell you what, on Wednesday, please try to do some of these homeworks so you have questions. Because I want to spend the first part going answering some questions. Because even though your My Math Lab doesn't have it, we're going to do these 3 sections. I'm gonna put those on there today. I'm not gonna make them that many questions. There's maybe 4, 5, or 6 questions in each section. But these next 3 sections, they start showing us how to solve equations. In other words, if we have stuff like this, how do we solve it? Or even larger equations. If we have stuff like this, how do we solve it? That's what these next 3 sections tell us about. And to be honest, I don't know who I asked what we should cover, why they left these off, because these, out of everything we've done so far, these are going to help us in the next half of this class. So these are what we're going to do on Wednesday. And again, the homework assignments, I won't make them long. I just want to make sure so you can practice doing them. I'll have one or two easy ones, a middle one, and one hard one. Just so we have practice, kind of like what we just did to this morning. And then again, we'll do those on Wednesday. All right, everybody. Thank you so very, very much. And I will see you all Wednesday.